Hi, this is a video of building an end-fed antenna using a 49:1 Bellon. Going to first use two cores for the Bellon, tape them together. I'm using Class H insulated tape, so it'll take high temperatures. That's called glass tape. It's usually made by 3M. Once the core itself is taped together, we're going to use this conformal coating to harden it up a bit, because this particular tape here has no adhesive on it. The reason to have this first coating of tape is to keep the enamel wire from being scraped on the edges when you begin to wind the core. You don't want to scrape the enamel off. This is a measurement of per turn, approximate, about 4 inches per turn. Now we're making a measurement of the twisted wire for the 2-turn primary side of the Balun. Going to put a nice hook in the one end, then begin to twist it. It's about 16 inches needed to go around the core twice and have enough left for terminating. Once the twists are made, you can begin winding the core, starting with the twisted end and then pushing that through and bending it around, and there should be enough there for the 2 turns, and that'll be the ground side or the start of the transformer. Once the 2 turns are made, we will take some Kapton tape and tape it down so they'll hold, while preparing to wind the necessary 14 turns for the rest of the Balun. I'm using 14 gauge wire to wind the Balun. This drawing from the internet shows how many people wind the 49:1. Shows pretty good detail and some of the parts involved. You want to keep as much space as possible between the turns, because the voltages can get pretty high, especially once you reach the end of the single piece of wire coming out at the end after the 14 turns. That's the high voltage point, and that you want to keep away from things as much as possible. The toroid core is now wound, and we got some more Kapton tape, and then we're going to put glass tape, more glass tape over it. That will kind of help insulate the enamel wire from the elements and so on, and we'll wrap a good layer of glass tape. This is the Class H high temp glass tape. So this, even though this Bellon's probably not going to get very hot, it will be able to stand quite a bit of temperature with the Class H insulation. With it fully taped, the next step will be to strip and tin the wire for testing. We'll do a quick test on the network analyzer just to see what kind of curve it has. Not that it'll tell us anything, because it's not going to be under load. It'll just kind of be a reference, just kind of a take a look. Just make sure that it does pass some of the lower frequencies, because we're actually interested most at this point in time is 160 meters. But we'll see. I'm just going to throw an old SO239 on here at the 50 ohm point between the ground and the 50 ohm point. That will be how we'll connect it to the network analyzer, and then putting a 2.4K resistor from ground to the 64 point, or the across the entire coil. And as you can see, we're at about 1.5, 1.38 SWR at 1.9 megahertz. So now we're going to coat it, spray it again with the conformal coating. This is the box, got from Menards, 4x4x4 PVC waterproof enclosure, and that'll mount outside for the Bellon to be protected. And we got to drill holes here for some stainless steel screws we're going to put in, and actually the holes are drilled so the screws will actually create threads through the holes to make things extra tight, just to help with keeping the water out. This is a chassis punch that will punch the hole for the SO239 and make a nice clean hole instead of trying to drill it or use a hole saw. This green leaf chassis punch works pretty well for this situation. These are the stainless steel screws. I use 1024s screws and so on. And here's how the punch will knock a nice clean hole through the side of the enclosure, and then we'll be able to mount the SO239 perfectly right there in that hole. Just got to drill out, mark and drill the 4 mounting holes. It'll be pretty much ready to go. Got to drill the 4 mounting holes using 440 screws that will tap right into the plastic. I tapped the plastic. I guess I didn't show that on the video, but I used a tap to make the threads, and then I'm gonna seal the SO239 and keep the water out. One of the screws will be an extra long. That's so you can tie the ground to it, extra nuts and so on, and that'll be a good place to tie the ground of the Bellon. So looking inside, you see the longer screw, and that'll come in handy when we're ready to mount the Bellon. Now we're soldering on some lugs that will go to the screws. That particular one is the one that goes to the ground. This one goes to the center of the 50 ohm side, which goes to the SO239 center. Then we also have to add an extra ground to come out to another bolt to actually tie to earth ground on the outside of the enclosure. So that's what that second ground is. That's tied along with the ground going to the SO239. So we solder that lug on for the external ground, which will go to earth ground. And that's that hole right there next to the SO239. And then the finish lead, which is the high voltage side, and we solder a lug to that. And once that's prepped, we'll be ready to put it in the enclosure. And we try to suspend it using the strength of the wire. Don't have it against any of the plastic, just in case one wants to run a lot more power through it. The coil, because it's Class H, will take the temperature, but the box might have an issue with it. So you want to suspend it as much as possible. So it's ready to mount and start construction of the long wire antenna. This is a 4x4 post. I concreted into the ground. Next to it is the 8-foot ground rod. And this shows the connections underneath the Bellon using RG8 coax. This is some weights to allow the rope from the top of the tower coming from the pulley, so I can pull up and down the dipoles without any problem. These are some of the insulators I'm going to use. The wire here is stranded 14 gauge copper. I found some of this on eBay in 100-foot rolls, so it seems to work quite well. This is the junction of the 200-foot copper wires, one on one side, one on the other, and they're stretched across the yard, not installed at the other end yet. Pulling up the rope with the pulley to the top of the tower, and also to that same tie point is one end of the G5 RV. So we have the end fed and the G5 RV all tied to that same area there. There's a view of the tie point 60 foot up the tower. There's the G5 RV. After some testing, I realized I need a load coil to lengthen the wire just a little bit. So 11 turns of number 14 seemed to do the job right at the peak of the tower. That's a 3-inch diameter, 11 turns of number 14, and it is tied between the two lines. Here's the end-fed resonant points, and here's the problem. The SWR at 1.9 is really high, and that's the band I really wanted to use. But at 3.9 on 80 meters, 75 meters, is excellent. At 5.3 on 60 meters is excellent. And at 7.2, it's excellent. So, just for the heck of it, I tried to parallel the end-fed and the G5 RV, which made some interesting results. So now, at 1.9 megahertz, I've got an SWR drop down to 2.8. 80 meters, not too good, 21.5. So, but it looks like 40 is pretty good. This is the G5 RV. I just tied that in just to take some looks at it, at the different bands. It's not as good as I thought at 20 meters, but it does work halfway decent. This is a drawing of the yard with the long wire antennas, the lengths, and the height. It starts out on a 4x4 in the backyard where the Balun is set up. There's 6 feet to the top of the 4x4. Then the long wire goes 48 feet to a power pole of 26 feet. And then from the 26 feet point, it's tied off with a screw hook and then an insulator with a spring. And then it goes up the tower 88 feet. At the top of the tower is where the load coil resides. Now from the top of the tower, come down the other side 90 feet to another power pole, not quite as tall as the other one. And another insulator and spring. And rather than cut the wire, I just ran the wire down the power pole to take up the extra slack. I gave it another few feet. And then it dead ends. Now for the G5RV, it is connected to a pretty rotten tree, so we hope this tree will last a little bit longer before I'm going to stretch it all the way back to another tree. But for now, it's going to this dead tree, 32 feet in the air at that end, and then back to the top of the 60-foot tower. And, of course, in the center is the ladder line. One issue is going to be the power lines that surround the area here. As you can see, the end of the long wire is not too far from the power line. So noise may be an issue at times. It has been with the G5RV. Have a noise canceling device that helps a little bit. Wanted to take one more look at the frequency band of the long wire antenna. And this problem here at 160 meters, it's got me. I haven't figured that out. We are so good though at 80 meters, 60 meters, and 40 meters. We're not too bad here at 20 meters, which is about 2.0 SWR. So why you can see that there's a resonant point here. It is at resonance right there. Before putting that load coil in, resonance was about here. It was about 2.5 megahertz. So we have a resonance. For some reason the SWR is high here. No tuner needed for 80 meters, no tuner needed for 60, and no tuner is needed for 40. I haven't tried 20 yet, but the long wire is working excellent here. So for now, I'm going to have to parallel and I don't know, I don't quite understand why it works, but I'm going to have to parallel the G5RV, so I'm going to do that right now. Paralleling the G5RV brings this 160 meter point down quite a bit, down to 5, still high, but 5 or so. Yeah, about 5.8 thereabouts. Of course, it really threw 80 meters off. It's got an SWR of 20, and it didn't do much for 60 meters. Didn't seem to affect 40 meters at all, and 20 meters really not affected that much either. So the G5RV in parallel makes 160 at least usable. But I still don't understand why the SWR is high, even though on the other plot it did have resonance. It was resonant, but just a high SWR. So that's to look into. And just another look at the G5RV. So at 160, way up 18. Even on 80 meters, SWR 7. 60 meters, it's really messed up at 17. At 40 meters, we've got a SWR of 5.2. At 20 meters, 3.6. So it is pretty good at 20 meters. Okay, we'll try some SWR tests here. This is 60 meters. Okay, we're zeroed here for SWR. Not bad. About 1.3 to 1. On the upper channel, it's actually lower. 1.1 to 1. Yeah, it's a little high at the low end of the channelized 60 meters. Okay, at 7,200. Look at that. Doesn't even move the meter. Lots of line noise on 80 meters at 3,900. So we'll do a check here. Set. Perfect. 1 to 1, or near to it. So that's at 80 meters at 3,900. There's 1.9. Ooh, no good. No good. Do a set. Okay, SWR. It's not too bad. It's about 1.3 to 1. Usable. Probably a tuner would help that. Well, there's the NIPSCO power line noise. Really bad today, really bad. Almost 20 over. Well, let's check the SWR. Pretty high at 1899, 1900. So where do we drop? If I bring it up, See, the Q's pretty high. See, we can go to 1950, and it's 1:1. Look at how high that Q is. So I can go all the way to 1999, and then it starts to come back up. So the only range I'll be able to use without a tuner will be about 1940 up to 2 meg. However, with the line noise, that's not good.